All right, we're back. All right, so this is a little more complex type of factoring. Remember, we're doing factoring by grouping. So if you're asking yourself, do I always have to group the first two together and the last two together? The answer is technically no. You don't always have to group it like that. In fact, if you see some things right off the bat, like I'm looking at 14x squared and I'm looking at 7x and it's like 7's going to both of those, it's a good idea sometimes to do just a quick reversal of it. And remember, we can do that because of the commutative property. The order doesn't matter with addition. You just got to make sure if this were a negative 4x, that the negative travels with the 4x down to this line. So now that things look a little bit clearer, that might be helpful for you. So then if you do the prime factorization, 14x squared and a positive 7x, 14 is 2 times 7. Seven x is 1 times 7. So they share an x, they share a 7. The GCF is 7x. My leftovers are 2x. And see, this is why I didn't circle the ones. Just to show you that if I circled everything, there's technically a 1 left over. So I don't want to leave this spot vacant because there were 2 terms up here. That means there should be 2 terms down here once factored. So a positive 1 remains. Now if you check out 4x plus 2, this is just 2 times 2. This is just 1 times 2. They share a 2. That goes in the GCF spot. And notice, like, right away I'm putting a plus here to have sort of like a clear, definable, oh, my GCFs create 7x plus 2. Make a habit of that. The leftovers, 2x plus 1. Surprise, surprise, looks exactly like what we had before. That's exactly what we need. So then the GCFs create the 7x plus 2. And then you have the leftovers combining for that term right there. Let's check it. Does 7x plus 2 times 2x plus 1 yield this polynomial when we multiply it out? So you put 7x on the outside, 2x plus 1, because we multiply the 7x times everything. Same thing with the 2. (14x squared) plus 7x plus 4x plus 2. Well, that's exactly what we had here once we reverse the order of it. Which I can even take it one step further and say, from the commutative property, 7x plus 4x is the same as 4x plus 7x. So I'm not going to require you to check these because I think sometimes it's like I literally just did that process where I took it from here to there, and now you're telling me to do it over again. Well, I think it's more just internally to say, like, I really get this and I'm absolutely sure I came up with the right answer. Or I'm absolutely sure that it was wrong because it didn't check out in the end. All right, on this last example, I want you guys to pause the video, try it on your own, but then I'm going to show you a way in which maybe we don't need to really do the prime factorization to accomplish this factoring business, okay? All right, so on our last example, you have 3ab plus 9a squared. Those look pretty good because they share a 3 and an a, so I don't think I'm going to be doing any rearranging here. Then you got plus 5b squared plus 15ab. And this group confirms it. They both have a b. They both seem to divide a 5. Well, haven't I just figured this out? Haven't I just done the work of factoring in that one little step? I just found out that they both divide 3. So that means that my GCF, my GCF is going to be a 3. And then they both have an A. So maybe I can just forget the prime factorization and just go right for the GCF. Now, what's a quick way to get the leftovers? Well, remember, we are doing the opposite of the distributive property. The distributive property is basically like saying multiply. Multiply one thing on the inside times, or one thing on the outside times everything on the inside. So if we're doing the opposite of multiplying, that would be division. So technically you can figure out what your leftovers are by dividing both parts by the GCF. The GCF was 3a. Divide this term by 3a. Divide this term by 3a. And if you remember how to divide, right, monomials, you can easily just say 3 divided by 3 is 1. A divided by a is 1. I'm left with the b. I can just put the b inside. 9 divided by 3 is 3. A squared divided by a is a. All right. I didn't mess with any messy prime factorization. That's good news, especially since it's a lot less time consuming. And I think it allows you a better visual cue to be like, oh, it's the opposite of multiplication, it's division. Let's do the same thing on this group right here. So here, we have a +5 and a +5. Certainly those both go into 5 and 15. So there's my GCF. So I'm dividing by 5, dividing by 5. And then I also have a b that they share. And they don't share anything else. So the leftovers will be 5b squared divided by 5b. 5 divided by 5 is 1. B squared divided by b is b. 15 divided by 5 is 3. B divided by b is 1, but there's an a left over. Which it's kind of like there's a duh moment that goes on there where it's like, hey, they're supposed to be twins every single time. All right, you got b plus 3a here. You better get b plus 3a over here. Okay, then you do the last move. In this case, it's really helpful because it's almost color-coded for you. The black ink GCF is its own term. 3a plus 5b. The blue ink becomes its own term. And then now we've created a polynomial that was nothing but addition, now has two factors multiplied together. That is the heart of what factoring is. So, I hope you found this video helpful, both of these videos. I'm just assigning like 5 problems, okay? The solutions to half the problems are given, so just check out Google Classroom, and we'll keep this factoring train moving along.